Good afternoon. Today, lecture number 9, Current Electricity. We have 5 questions: electric current, superconductivity, carbon resistor, combination of resistors, temperature dependence of resistance, and Kirchhoff's law. And the first question, and electrical current. Electrical current, we know, and the first so we'll study and the chapter, the chapter electricity and magnetism, and the branch of physics which is the deal with the study of motion electrical charge in the called current electricity. In a metallic and charged metallic conductor at rest, that not all electrons are continually moving randomly through the conductor because they are very lowly attached to the nuclei. And the flow of free electrons in a conductor continues the electric current. And we know the characteristics of electrical current, and the first characteristics and current, and the current is defined as the rate flow charge across cross-sectional area of a conductor. We know if net charge passes through any cross-section of conductor at the time, the electrical current equal electrical charge divided by time, where is the Q electrical charge and T, this is time, and the system international unit of the current, ampere. If the rate flow of charge is not uniform, the current varies with the time and instantaneous value in here. Instantaneous value of the current is given by in here, the instantaneous current. Current is a scalar quantity, is the direction of the current is take the direction of flow of positive or opposite to the direction of flow of electrons. And here the figure current carrying conductor, and consider a conductor XY connected to a battery. The study electrical field intensity is established the conductor in the direction XY, from X to Y. In the absence of the electrical field, the free electrons in the conductor move randomly in all possible directions. In possible direction, in here, this is direction of the current and direction of the electrical field. But we are in here the negatively electrical charge move and the compare with the direction is from Y to X, and current carrying conductor. Okay, drift velocity is defined as the velocity with which the free electrons drive towards the positive terminal when electrical field is applied, and drive velocity and acceleration multiplied by time. And we know they're using formula of Newton's second law, and here this is mass of the electron, and force experienced by electron of mass, and the flow hence in here acceleration equal, and electrical charge multiplied by electrical field, and here this is force, will be force and divided by mass. And we know formula of the acceleration and the changing velocity by drift velocity, and replace acceleration, drift velocity divided by time, and final formula drift velocity and mu multiplied by electrical field. Where is the mu? Mobility, and they define the drift velocity occurred per unit electrical field, and here. And they take the unit of mobility meter square, volt multiplied by volt -1 and second -1. And the electrical current density J, and therefore the current flowing across a conductor having the the cross section, and electrical current divided by area, and final formula, and current flowing across a conductor having the area of the cross section A. The current density is a vector quantity because in here this is this is current density, electrical current, and the direction of electrical field. The vector here vector quantity, the compressed and current density, the unit current density of system international unit, and ampere divided by square meter. You know, and the total, the number of conduction electrons in the conductor equal N, A, and L. The electrical charge of the electron equal A, and the total charge passed through the conductor and electrical charge equal MAL multiplied by E, and the time is which the charge passed through the conductor, and L divided by Earth's velocity, and the current flowing through the conductor, and we now formula electrical charge divided by time, and got time and replace in here, and electrical charge replace, and final formula of the electrical current flowing through conductor, and this is formula, and A is the area, electrical charge, and root velocity in here. The current flowing through the conductor is directly proportional to the root velocity and current density. Current density formula, electrical current divided by area, and put on the replace and A, and electrical current through flowing through a conductor, and final formula N, E, and velocity in here. Okay, and we know, and the in here the we know formula electrical field of the ratio and potential divided by L, and V, and here the potential difference, E, and maybe we take and replace and E, potential divided by L, and the final formula of the electrical current through the conductor. The quantity is a constant for a given conductor called electrical resistance, and electrical current proportional potential difference. The low state and the constant temperature, the steady current flowing through the conductor directly proportional. Potential difference between two ends of the conductor. We know formula of the Ohm's law, and potential and electrical current proportional potential difference and divided by resistance. We know, and here this is Y axis, and this is the direction of the electrical current. In here X axis, and this is the direction of the potential difference. The resistance of the conductor is defined as the ratio of potential difference across the conductor to the current flowing through it. The unit of the resistance we know is ohm, and here in the unit the reciprocal of resistance is the conductance. It is units of the ohm, ohm minus power minus 1. Okay, and the resistance are proportional, and the proportional length of the conductor, and inversely proportional area to its area cross section A in here, and this is formula and resistance of the conductor, and rho and the specific resistance of or electrical resistivity. We know we take and length of the conductor 1 meter, cross sectional of the area equal 1 square meter, then and specific resistance equal resistance of the conductor. And we are now and the and the unit of the specific resistance ohm multiplied by ohm is a constant for the particular material. The reciprocal of electrical resistivity is called electrical conductivity, sigma equal 1 divided inversely, and reciprocal of electrical resistivity, inversely proportional and specific resistance, and the unit of conductivity is O-1 multiplied by meter, power -1. And here this table, electrical resistivity at room temperature, and material different for different materials. And here this is for these materials following and specific resistance. Okay, and ohm multiplied by meter. We know in here this is materials and classification: conductor, semiconductor, and insulators. Okay, and the second question, superconductivity. We know the phenomenon of superconductivity observed on cover length ohms and 1911, and I have found the mercury suddenly showed zero resistance at zero resistance in here. This is and true and the figure superconductivity of mercury and zero when resistance equals zero, and the temperature equal 4.2 Kelvin. The first theoretical explanation of superconductivity was given by Bowden, Cooper, and Schripp in 1957. Is called BSS theory. And here this is Y axis we enter. This is the direction of the resistance of the conductor, and here this is x axis in here. This is and value and temperature was Kelvin. The temperature to which electrical resistivity of the materials suddenly groups to zero. The materials change from normal conductor to a superconductor is called transition temperature or critical temperature, TS. And here this is critical as the temperature. And question number three. Question number three: carbon resistance, combination of resistors. And we know two type combination of resistance, and this is connected and parallel, and series and parallel. Resistor and series we know, and the first resistance connect and the second and third source. If we can formula on the total resistance calculated on the total resistance, because the total resistance will be the every resistance and plus the sum of resistance, this is total will be total resistance, and the torque and electrical current is a constant, because this is in series, and voltage and total voltage equal total voltage and number one and second and third and number and 4 voltage, and the net potential difference. This is formula. This is potential difference, the total potential difference, and electrical current is a constant, but the total resistance and resistance, the first resistance plus the second and third and fourth, and there will be the total resistance. And here this scholar code for carbon resistance we know, and the different resistor in have and color, and black resistor are 0, number 0, brown 1, red 2, etc., orange, yellow, green, and blue, violet, gray, and white. And this is common number of color code for carbon resistance. Okay, we're using Ohm's law. We know from Ohm's law we calculated voltage for every resistor for every resistor. If we know potential difference, the first resistors and the second and third and fourth and one final in here. RS and is the equivalent or effective resistance of the series combination. If we know the formula and the total R resistance series and R1 and plus R2, R3 and R4. We know that this equivalent resistance of a number of resistors in series connection is equal to the sum of resistors of individual resistors. But in the second type, the second connected type and parallel resistor in parallel, we and here this is which when and we take and four resistor in and connected in parallel. We know and maybe and the current and resistors and as a current and will be and the first current plus second current, third and number four, because and the current cut and the four lines in here. And we know and the by and using Ohm's law, we know formula for Ohm's law. We are using formula Ohm's law for different resistance. If we know in the first current potential difference divided by R1, the second current, the third and the fourth and total. What is the RP and the equivalent of or effective resistance of the parallel combination? If we know and in here this is formula of the and when a number resistor connected in a parallel, the sum of reciprocal of resistance of the individual resistors is equal to the reciprocal of the effective resistance of the combination. And question number 4. Question number 4, temperature dependence of resistance. We know and the resistivity of the substance, where is the temperature? For conductors, the resistance increases with the conductors or the resistance increases with the increase in temperature. If there is the resistance of conductor and at temperature equal 0 degrees Celsius, at the resistance of the semiconductor at T degrees Celsius, when and here the formula of resistor proportional to the temperature. We know in the R0 this is a resistor of the conductor temperature 0 degrees Celsius. Alpha is called temperature coefficient of resistance. We calculated calculated and coefficient of resistance equal of the ratio and change resistance the final resistance and minus the resistance for on the temperature for the temperature equal 0 degree Celsius and divided by 0 T multiplied by T. And here this is a figure following variation of resistance with the temperature. Variation is resistance with the temperature. Even in here, increasing increase the temperature, increasing resistance in here. And this is a line show you and proportionality temperature increases and increases resistance. And metals we have metal have positive temperature coefficient of resistance. The resistance increases with increases the temperature, but insulator and semiconductor have negative temperature coefficient of resistance, or the resistance decreases with the decreased temperature. And here and for metal, for the conductor and increases temperature, increases resistor, but and semiconductor and insulator and decreases temperature and decreases resistance and decreases resistance with increases in temperature. And materials and negative temperature coefficients are called thermistor. The temperature coefficient is low for allows. And the final equation, Kirchhoff's law, we know Kirchhoff first law and Kirchhoff second law. Kirchhoff first law and the name and current law. In here, this is figure. Kirchhoff current law states the algebraic sum of the current meeting at any junction in the circuit is zero. And the current flowing towards the junction is a positive, and current flowing away from the junction is a negative. And here this is the 5 current, and the first here the current and 2 and 2 junction O and 1 and 2 and 3 and 4 and 5 be the conductor meeting junction O in an electrical circuit. And E1 and E2 and 3 and 4 and 5 and the currents are passing through the conductor respectively according to Kirchhoff first law we know, and then the electrical current E1 and the 2 O junction and the positively, but the current from junction O, and here the current is negatively, and the E3 and E3 is relatively 2, E4, E5, E and equals 0. This is the formula following and Kirchhoff's law and current law. Kirchhoff second law, voltage law. In here they consider electrical circuit and figure. Kirchhoff's law. Considering closed loop, and here A, B, C, D, E, F, A. Even now, and here E1, R2 is a positively, and E3, R4, the positively 2, E3, R3, and here the source. And positively E3, E3, R5, I'm sorry, E3, R5, and here positively 2 plus E4, R6, R6, and positively 2, E1, and here E1, R1 as a source, and here E3, R3, and here this is source, E1, R1, equal, and here this is closed loop, consists to electromotive force E1, E3. It will be E1, E3 is a positively because the current and E1 in here this is E1. And here through the source in the positively, E and E3 is positively 2. Positively 2, both in the cells E1 and E3 send a current in clockwise direction. For the closed loop ABE, and here FA, the closed loop in here E1, R1 plus is a positively, this clockwise, E2, R3 is a positively 2, E2, R2, this is source, and then the next E4, R6 to positively, E1, R1 is a positively, E1, R1 is a positively 2, equal E1 electromotive force, the first electromotive force, and electromotive force, and here this is electromotive force, the second is a negatively because this is negative, and is a second source, and indicates the current in the anti-clockwise direction because E2 is a negative cell. And the illustration of application in here, the second law, let's have the calculated current in the fluid network. And here this is, and we study today electrical current, the definition electrical current, and the formula of the electrical current and current density, resistance, and two type resistors, combination of resistance and series and parallel, Kirchhoff's law, and we studied and Ohm's law. Ohm's law and here. Okay, thank you for attention.